Hello and welcome. Today we'll cover the 5 non-negotiable standards you should always check when evaluating heating film quality. In the field, many products look similar on the surface, but real quality shows up in heating uniformity, connection stability, durability, and inspection control. Our 5 keywords are carbon, silver, copper, bonding, and quality control. These cover what creates heat, what stabilizes connections, what delivers power, what protects the structure, and how quality is kept consistent. For each one, we'll explain what high-quality products do differently, and where low-cost products typically start to fail. First is the carbon heating layer, the part that converts electricity into heat. The key concept here is dispersion. In high-quality film, carbon particles are evenly dispersed, which keeps resistance stable and produces a more uniform surface temperature. In low-quality film, poor dispersion or impurities can cause current to concentrate in specific areas, leading to localized overheating, hot spots. Hot spots aren't just small warm points. Over time, they can lead to floor discoloration and reduce product life. So carbon quality affects not only efficiency, but also safety and durability. Second is the silver bus bar. You can think of silver as the critical interface that allows current to transfer reliably between the carbon layer and the copper electrode. What matters most is the density and coating thickness of the silver. In high-quality film, high-density silver is applied with sufficient thickness to minimize contact resistance. In low-cost film, manufacturers often reduce the silver content or use lower-density material, which increases contact resistance. And when contact resistance goes up, two things usually happen. Connector areas overheat and overall output drops. Silver is a major cost driver, but it's also one of the clearest indicators of electrical stability. Third is the copper electrode, the main pathway that delivers power across the film. Here, the most important factors are purity and thickness. High-quality film typically uses rolled copper foil with 99.9% plus purity, offering high conductivity and better corrosion resistance. Low-quality film may use lower purity or thinner copper that oxidizes more easily. When copper turns dark from oxidation, it's not just a cosmetic issue. Oxidation raises resistance, which can increase localized heating and create safety risks. In short, copper is the power highway, and its integrity directly affects lifespan and reliability. Fourth is bonding, the insulation film and adhesive system. Heating film repeatedly expands and contracts as it turns on and off. This is called thermal cycling. The point where quality often separates is interlayer bonding strength. High-quality film uses high-temperature PET and appropriate adhesives to reduce deformation. Low-quality film may use PET or adhesives that can't handle heat well, leading to warping, bubbling, or delamination. Once layers separate, moisture can enter, accelerating internal corrosion, ultimately reducing insulation performance and service life. Bonding may be invisible, but it is a critical shield for long-term safety. Finally, quality control, especially 100% total inspection. Even with great materials, products can fail in the field if inspection is weak. Low-quality production often relies on sampling, which can leave significant lot-to-lot variation. High-quality production measures resistance and insulation performance across the entire length. This approach catches even micro-defects early and greatly reduces mystery failures on site. Total inspection is how a manufacturer demonstrates real responsibility for safety and reliability. To summarize, heating film quality is determined by carbon uniformity, silver contact resistance, copper purity and corrosion resistance, bonding durability, and 100% total inspection. When comparing products, don't judge by appearance or price alone. Use these 5 standards to assess quality accurately. Thank you for watching.